Hello everyone again, and in this video this is the last lesson about logarithms. Um, we will explain each type of questions in this video. First of all, I need you to know that logarithms is in different form or different shape of the index form. When we say 5 power 3 equals 125, you can rewrite this in logarithms form. This power and this base, we write log to the base 5 because this is the base of 125. The answer is 3. It means how many times the 5 was repeated or raised to which power to give us 125. So in our case here, this means 11 raised to the second power, 11 power 2, because we said this is the base and this is the power, and the result here equal 121. Okay, this is the inverse of this, of the last one, the base and the power, which, and this is the answer. So log of 70 to base x equals y. Here we have division and the power. We have three properties. If we have log a multiplied by b, we have one log of multiplication a times b. We can expand this to be log a and log b with addition. Okay, if log a over b, we can divide this in two logs, log a, but division is subtraction, log b. Okay, so in this case we have log a squared minus log b, but we have the third one. If we have log, for example, x power a, this power is moved before the log, so a log x. So can we apply the three rules here, or two of them? Yes, we can write 6. Okay, 6 log a squared minus 6 log b, because this 6 is all on a and b, so it's for both logs. 6 log a power 2 minus 6 log b. Now we have 2 also, we need to move this here. It will be 12 log a minus 6 log b. Okay, I may do a different one to make. Can you try this by the same rule? We have subtraction. This will be log x power 5 minus log y power 6. We said that division switch to be subtraction. Then 5 and 6 will be 5 log x minus 6 log y. Okay, I think this is clear. Now this is the opposite. We have subtraction and we have 4. It will be a power 4 and b power 6, and they are divided because this is subtraction, so it's only one log of division. So this is the answer. Okay, this is the last part, how to graph the logarithm function. If the question was log x, we go to this origin and we move to the right one step at one and graph. This is the first part and this is the second part. It goes, approaches y, but it doesn't beat with y. But in our case it's -2 plus 5. We have horizontal shift and vertical shift, so this is translated to be +2 and this is +5. So instead of graphing here, we need to move 2 units right and up 5 units here, and here we have our new axis. Before we start, we move one unit right and start by sketching the graph. Okay, if you think you didn't catch everything in this video, I will go back to a specific sheet of the logarithms to make sure that you understand. Okay, let's try this. We said that we need one without explanation. This is the base, it's 11. This is the power, n equals m. Okay, for example, this is the base, so it's log base 14. This power is 2, and here 196. Okay, here we said that multiplication is we divide in two logs, log but with addition. We said that multiplication changed to be addition, and this is log 8. Before we expand, we need to move this power here 5 log 8 and 5 log 7 power 3. Then this stays the same, and 7 power 3, the 3 is multiplied by 5 because we move all powers. 15 log 7. This is the same. You can stop the video and try it. The same here, 6 log base 4 u power 3, and the 3 will move with the 6 to be 18, and 6 log v. Okay. Okay, we didn't talk about how to solve logarithms equations. Let's go back to the model. Okay, how to solve this, for example. Okay, to solve this, we have two logs and we have one log to the right. Remember that you need one log to the right side and to the left side and one log on the right side with the same base. We have this, but we have two logs in the left side. Do you remember that subtraction is we can bring it back again to the division? So this could be log base 4 negative x over 2. We divide this equals log base 4, and this is 12. If you have two logs right and left side with the same base, we can cancel them. So this is negative x over 2 equals 12. Here negative x equals 24, so x equals negative 24. So can we put negative 24 here? Yes, negative negative 24, so this is positive 24, so the answer is exact. So we have the answer negative 24. Let's do a different one. Okay, this one, let's try to solve this. Yes, this example is good. Before we solve, remember you need log 6 base 6, log base 6, and you need here log base 6. So it's okay to add log base 6 but to 6. So it's clearly known that we can add log 5 base 5, log 10 base 10. It's okay because they all equal to 1. So we can add log 6 base 6. Why 6? Because we can cancel this later. So we need to make only one log here. It's log 6. This multiplication is originally this addition is originally multiplication. So this is x plus 3 multiplied by 9. Now we have one log on the left side, and this goes back to the power, so it's log 6 and 6 plus 3. Now we have log 6 base 6, log base 6 and log base 6 in both sides. We can cancel them. Expand this, 9x plus 27 equals 116. We can move this and solve. But I need you to remember with the first note, we need one log left side and one log on the right side. Let's go back to the first example we saw here. Log 7. We need to add log 7 base 7. Okay. Multiplication. We can bring it back to addition. Sorry, this is addition. We can go back to the multiplication. So this is x log base 7. X multiply x plus 6. And this is log 7 base 7. Now we can cancel this. And this is x squared plus 6x equals 7. X squared plus 6x minus 7 equal to 0. And we can solve this by modifying 3. The answer will be 1 and negative 7. But when we replace negative 7 here, this will be rejected because we don't have log of negative. So the answer is